Good morning, dear students. I guess all of you are very fine. I'm very glad to have you here once again on Dhaka Online School. You are most welcome. I'm going to introduce myself. As you know, I am Nirupama Roy, Senior Teacher, South Point School and College. And today, I'm going to take your science class of class 8. Okay, you can see some equations here. What kind of equations are they? They're mathematical equation. I know you are very familiar with this mathematical equation. Like this kind of equation, we have another kind of equation that we call chemical equation. And our today's lesson is chemical reaction and its chemical equation. And our today's learning outcomes, you will explain chemical equation. You can also explain the rules of writing chemical equation, and you will be able to explain chemical reaction of addition. Okay, so let's start our class. Here you can see a chemical equation like 2H2 plus O2 equal to 2H2O. So what is a chemical equation? A chemical equation is a shortened expression of a chemical reaction. So whenever we have a chemical reaction and we wanted to express that chemical reaction in a short form, at that time we use chemical equation. In chemical reaction, we have two parts. One is reactants and another one is products. So let's see what are these. If we have a chemical reaction like hydrogen and oxygen making a chemical bond and producing water, then we can write the chemical equation like 2H2 plus O2 equal to 2H2O. And here you can see on the left hand side of the equal sign we have 2H2 plus O2. This is called the reactants. And on the right hand side of the equal sign we have 2H2O. That means water. We call this part is product. So in chemical reaction or chemical equation, we got two parts or two things, that one is reactants and another one is product. So what is the left hand side on the equation? We called that one is reactants, and on the right hand side of the equation we call that one is product. Well, for another example, suppose we have sulfur and oxygen and they make a chemical bondage, and after that chemical bondage we got sulfur dioxide. So here in this chemical equation we have sulfur and oxygen on the left hand side. That's why these two elements are called reactants. And as a result of this chemical reaction we got sulfur dioxide. So this sulfur dioxide is called product. So from the previous examples we have some points like reactants represent the prior state of the reaction and the products are the resultant state of the chemical reaction. Another point is, in any chemical reaction, atoms cannot be created or destroyed, but they are rearranged only. In this chemical reaction, the atoms of hydrogen and oxygen are neither created nor destroyed, rather they rearranged themselves and make a new product which is water. In chemical equation, the total number of atoms present in the reactants before the reaction always equal to the total number of atoms of the product after the reaction. And it uses some symbols, formulas, and some mathematical signs to denote the reactants and products. Okay, let's see an example. Like we have two reactants here in this chemical reaction, zinc and sulfuric acid, and we have also two products in this chemical reaction, that are zinc sulfate and hydrogen. The total number of atoms present in this reactants before the chemical reaction, you can see here how many zinc atoms are there, 1 on the reactant side, and here in the product side you can also see how many zinc atoms are there, 1 zinc atom are there. And for the reactant side, sulfuric acid, how many hydrogen atoms are there, 2 hydrogen atoms are there. Here on the product side you can also see there are 2 hydrogen atoms. And for sulfuric acid, how many sulfurs are there, 1. And here 1 sulfur atom on the reactant sides and 1 sulfur atom for product side, and 4 oxygen atoms on reactant sides as well as 4 oxygen atoms on product side. So whenever we are having the atoms on the reactant sides and the product sides, they are all equal. Here you can see plus symbol or plus sign is used in this reactant parts and as well as in the product side in this chemical equation. And here we have also used an arrow sign for reactants to products, that our chemical equation is going from reactants to the product side. If we add the total atoms on the reactant side, we will get here zinc, how many atoms of zinc here, 1. How many atoms of hydrogen here, 2, that is 1 plus 2, 3. Sulfur is 1, that is 4, total 4, and oxygen atoms are 4. That means total atoms are on the reactant side we have 8 atoms. So total number of atoms on reactant sides we have 8 atoms. And on the product side you can see how many zinc are here, 1. How many sulfur, 1. How many oxygen atom, 4. And how many hydrogen atoms are here, 2. So if you count this 1, 1, 4, we got 6, and this 2 we got 8. So on the product side we have the total number of atoms are also 8. Okay, there are some rules of writing chemical equation. Let's see what are they. First rule is, in a chemical equation the formula or symbols of the reacting substances or reactants are written on the left of the sign of equality, and the symbols or formulas of the products are written on the right of it. As we see on our previous example, zinc and sulfuric acid are the reactants here in this chemical reaction. These reactants are written on the left hand side of the equality sign, and the products, that are zinc sulfate and hydrogen, they are written on the right hand side of the equality sign. Here zinc and sulfuric acid are the reactants that are written on the left hand side of the equal sign, and zinc sulfate and hydrogen are the products of this chemical reaction, and they are written on the right hand side on the of the equal sign. Another rule, you can see here, if the reactants or products are more than 1, a plus sign is put between the formula and the symbols. Here you can see we have used a plus sign between zinc and sulfuric acid because we have two reactants here, so the plus sign is used between these two reactants. And on the product side we have two products as well, that's why we also used this plus sign between these two products. Another point or rule of writing chemical equation is, if the number of molecule is more than 1, then the number is used before the formula. So let's see what is this point. Here you can see hydrochloric acid and magnesium. These two reactants make a chemical bondage and they produce two products. One is magnesium chloride and another is hydrogen. Here for hydrogen chloride we have two molecules of hydrogen chloride here. These two molecules of hydrogen chloride is written, this 2 is written before the formula of the hydrogen chloride. You can see here this 2 is written before the hydrogen chloride formula. Here this 2 indicates that there are two molecules of hydrogen chloride are there. Another point is an arrow sign is used to indicate that the reaction moves towards the products from the reactants. Instead of an arrow sign, equal sign may also be used. However, the equation has to be balanced on the both sides. How? Okay, let's see. Here you can see we have used a arrow sign in this chemical equation. Hydrogen and oxygen. If you count the atoms of hydrogen on reactant parts and the product part, you will see here we have two hydrogen atoms, and on the product we have also two hydrogen atoms. But if you observe here, the atoms of oxygen on the reactant sides are 2, but on product side we have one oxygen atom. So the atoms are not equal on reactant side and the product side. So we do not give the equal sign here. That means we are using the arrow sign here. It indicates that reaction moves towards the products from the reactant sides. But the equation is not balanced. Whenever we have a balanced equation, that means on the reactant side and on the product side we have the equal number of atoms of reactant and products. At that time we can use the equal sign. Okay, now let's see. Here if you observe carefully, you can see on the reactant side the number of hydrogen atom are 4, that is 2 into 2 equal to 4. So we have 4 hydrogen atoms on reactant side, and for the product side we have also 4 hydrogen atoms, like 2 into 2 we have 4, that means 4 hydrogen atoms. And on the reactant side we have 2 oxygen atom, as well as on the product side we have also 2 oxygen atoms. So on the left hand side and right hand side, that means on the reactant parts and the product parts, both parts the number of atoms are same for the reactants and product. That's why now we can use the equal sign here. That means this equation is not balanced, but this equation is balanced. Why? Whenever we have the equal number of atoms on reactant parts and product part, that means we have a balanced chemical equation. And when we do not have the equal number of atoms on reactant and product parts, that means that chemical equation is not balanced. Whenever we have an equation that is not balanced, we will use arrow sign from reactants to product. It indicates that the chemical reactions is moving on to the product parts from the reactant parts. And whenever we have a chemical equation that is balanced, that time we will use the equal sign between the reactant and product. Okay, another rule is the number of atoms of different elements present in the reactants before chemical reaction must be equal to the number of atoms of the different elements in the products formed after the reaction. So to make balance, the symbol or formula must be multiplied by the required number. Okay, let's see here the example. Hydrogen and oxygen, that two reactants makes a chemical bondage and make a product, that is water. You can see this is not a balanced equation. Here we have two hydrogen atoms and two hydrogen atoms on both reactant and product part, but we have two oxygen atom on the reactant parts but one oxygen atom on the product part. So to make this equation balanced, what we can do, we can multiply this one molecule of water by 2. That means we got here 2 molecule of water. Here we have now on the product side 4 hydrogen atoms and 2 oxygen atom. But if you see on the reactant sides, there are two hydrogen atoms and 2 oxygen atoms. They are not balanced either. So if we give 2 here before the 1 molecule of hydrogen, that means we got 2 molecule of hydrogen here. And how many hydrogen atoms are there in this 2 molecule of hydrogen? 4. Now we have a balanced equation, because in the both side, if you calculate, we have 4 hydrogen atom, 4 hydrogen atom and 2 oxygen atoms, 2 oxygen atoms. So now we have a balanced equation, chemical equation. So now we can give equal sign instead of arrow sign. Now let's calculate the atoms on reactant and product side. Here 2 molecules of hydrogen, and in each molecule of hydrogen we have 2 atoms, that means 2 into 2, plus here how many molecule of oxygen is here? 1, and in 1 molecule of oxygen we have 2 oxygen atoms, so 1 into 2. On the product part we have 2 molecules of water. Here you can see this 2 indicates the 2 molecule of water, and in 1 molecule of water we have 2 hydrogen atom plus 1 oxygen atom. So 2 plus 1, this is in 1 molecule of water, and into 2, this 2 is for 2 molecules of water. Now 2 into 2 we have 4 plus 1 into 2 we have 2 equal to 2 plus 1 we have 3, 2 into 3. If we add this 4 plus 2 we got 6, and 2 into 3 we got 6. So on the both reactant and product we have 6 atoms on both sides. That's why this is a balanced equation. Now let's see a video. Here in this video you can see chemical reaction between iron and sulfur is going on. So here sulfur and iron are mixing very well. And what happened? Observe the video carefully. Okay, in the video you have seen that there was iron and sulfur. When this yellow color sulfur adding with the iron and they heat up, they make they combine with each other and they produce a new kind of material that is called ferrous sulfide, ash color ferrous sulfide. Whenever more than one elements are combined with each other and make a new kinds of material or new kinds of substance, that kind of chemical reactions are called synthesizing reaction. That means here two types or more than one types of elements are combining or adding each other. Okay, let's see another example. Here we have zinc and sulfur. When these two elements combine each other and produce a new substance called zinc sulfide. Here you can see zinc and sulfur, they both are elements. They are combining or adding each other and making a new substance that is called zinc sulfide. So this is also an example of synthesizing reaction. So these two examples of reactions, compounds are formed from elements. You can see both the reaction I have given in this example and the previous example that was, I can show you, that was iron and sulfur. Both the examples here are shows that both the reactants are elements and they are making a compound. Whenever the elements are combining each other, they are making a new substance or new compound. Okay. And here you can see ammonia and hydrogen chloride. When in this chemical reaction, they are combining each other and making another compound that is ammonium chloride. Here you can see in this example, ammonia is a compound and hydrogen chloride is also compound. So these two compounds are combining each other and making another substance or new material that is called ammonium chloride. So previous two examples were showing us the elements were combining each other and making a new compound, and here you can see compounds are combining each other and making another substance or another element. So these kinds of chemical reactions where elements are combining and elements and compound are combining and compounds are combining and making another material, new kinds of substance, that kind of chemical reactions are called adding reactions. Okay. So this is the example of addition reaction. And whenever element and element are combining, this is also addition reaction, but it has a specific name, that is synthesizing reaction. Okay, that's all for today, my dear students. I hope all of you will be very fine at your home. Stay safe, stay at your home. Thank you very much. See you in the next class.